time. And we're going to have so much fun like we do in every lecture as we're on recordings. All right. Grab those coffees, grab those snacks, grab the ability to put up with me for about an hour to an hour and a half with my dog jokes and all that, even the dad jokes sometimes thrown in, because it's time for another lecture. All right. Today, we are looking at this cute little dog that can't fetch. Oh my gosh. Oh, it's right in the face. Oh, that's so cute. All right. Anyway, fetch and JSON. My attention span is like this right now, but I'm fully here. So let's go ahead and start learning this stuff. Fetch and JSON. First all, as always, announcements. Have not that many for you guys today. I'm sorry. First things first, assignment number 5 is due March 31st. Why I'm telling you this is that today officially I was given word by Clark himself that after today's lecture, you'll have all the knowledge necessary to complete assignment number 5. So if you are ready and willing, feel free to start reading that assignment after this lecture. If you already haven't, if you already have, air high five, awesome sauce. What else is there? So today we do have a studio review at 8 p.m. as always. I feel like I had something else to tell you guys. Oh no, if it comes across my mind,
So,
I will remember. Oh, this is right.
Kyle,
I heard somebody. What's up?
I have a quick question. My calendar, and I definitely could be wrong. So it's due, the assignment 5 is due March 31st. Don't we have 6 total assignments? And I thought the 31st was the cutoff day for 6. I might be confused.
Let's go ahead, and that's why I always have this thing up. Close your eyes. You haven't seen the stuff yet. All right, March 21st here. I got that. Oh, and Clark, if you're on the line, I see that assignment number 5 here is the graded assignment is due here on the 21st. 31st, I'm seeing the 6th one due.
Okay.
And that will be the drop assignment. So everything's got to be turned in by the end of the cohort, or by the end of this unit. That is the big thing. It's one thing I didn't really want to push too much today because I did mention it last week, but yes, it should be in the back of our minds. But yeah, 21st, the 5th assignment, and 31st, the 6th.
Okay.
Awesome. Thank you. Let's go back over here. Great question. Anything else? Any other questions out there? Oh, I got one here. Everything has to be turned on 1 and 1 points by March 31st, but if we turn it on the 31st, we won't get the grade. We won't know the grade yet. Yes, make sure all your stuff is done by the 31st. If it is in and your TA knows it's in, it's not like you're automatically dropped. We're not robots. We will work with you. But know that everything has to be in there before the 31st. And if you have any questions about that, reach out to Clark. But again, it's not an automatic thing. It never is. Like, we're people too. We get it. But it is a very, very strict drop date, due date on that 31st. So just make sure everything is done by then. And turned into your TAs. Great question there. Any other questions out there? All right. Then let's go ahead and get started here. Oh, I'm all giddy. Probably the caffeine, but I'm giddy about this stuff too. What I want to talk about is, I want to clear some air that we had last, or maybe some bad blood, if you will, that we had last lecture. I love it, love it, love it when students come up to me and ask those questions, or virtually up to me, if you will, about something that happened in a lecture that maybe they were confused about, or just trying to correct me. If you see something wrong in these lectures, please feel free to correct me. I love it when you all will come and test me about something maybe I said. I do not mind it at all. If I said something incorrect, I don't want you all to know that. So one thing that wasn't per se incorrect, but I do want to clarify here, is a slide from the previous lecture, and that was this slide right here. So we saw, and remember all this fun stuff, we have domain names, and they are transferred or transformed into IP addresses using that DNS there. Technically, none of that flow was incorrect. You still have a domain name. It gets transformed into an IP address using the DNS. But the thing I really want to call out is this IP address directly. This IP address, as it stands, is not correct. This is not a possible IP address. There were a bunch of these in our lecture that I have. I literally just typed out random numbers in 4 different sections, knowing that they're not correct IP addresses, but I personally did not go back and correct those. So I apologize if this was confusing to anybody, especially if you already know what an IP address or a true IP address looks like. So let's quickly talk about why this is not a correct IP address. As you can see here, there are 3 dots, 3 periods there, creating 4 different sections. Each of these sections can only go, their numbers themselves can only go from 0 to 255. 0 to 255. If you're wondering why, that's base 16 numbers. For the student that called it out to mention that to anybody else, also we use base 16 because it does eventually, like all things in computers, get transformed down into binary. But for IP addresses for version 4, our addresses can only go from 0 to 255 in each of these 4 sections. So a more accurate IP address or public IP address would be something like this. So we have 72.12, 124, 135. So this would be more of a public looking address. Now, if you ever played around with your IP addresses on your local machine, not your public IPs, they don't really look like this. But if you are ever curious also what your own public IP address is, feel free to go to whatismyip.com. I'll just show you your address. Can you do much with it? Not really, not just yet, unless you want to get into some networking stuff, but it's just fun to know. So some other IP addresses that I do want to call out here is that you will kind of see these, if you're playing on your local machine, things that are starting with 192. 192, 168, 01. Technically, if you type this into your router, you type this into your browser, some of your routers that are actually connecting to your internet will show you a login screen because you're trying to log into that router because you're on your local network. Other local IP addresses will start with 172 for different types of local systems as well as 10, but this is the most common one that you'll see, 192. So again, this is called a local IP address, and headphones, you're already dying on me. Knew I should have plugged them in earlier. The other type of IP address I really want to just call out real quick, just for fun, is 127.001. This is going to be a more important one as we get closer into the future with some other stuff that are coming up in other sections. This is also referred to as localhost on your local machine. So if we're looking at these 3 types of IP addresses, we start with public-facing stuff. That's the first one we just saw. Then we have local network IP addresses. Those are those 192s. And then you have it down to the local one on your machine, your true machine. The only true home address that you really have is the 127 one. That goes to your specific device. So as you can see, IP addresses really do play a huge role in just communication between devices. And in the end, wanted to correct or clarify what IP addresses will truly look like. So that was it. Again, love the comment just because I get to go in deeper with this stuff with you all. So any questions about this, anything at all? Not that it really pertains too much to what we're learning about. Just wanted, again, get into some fun topic before we get into other stuff. Yeah. Everyone's just taking it with stride? Cool. All right, give me 1 second. We'll continue on. We'll see how much that case actually charged, so I can actually have my headphones somewhat during this lecture. Okay. Now I've been talking enough. Now it's all of your turns. Let's go ahead. Help me out here. We see some code here, but my question to you is, what language is this? Definitely not German, definitely not English. What is it?
CSS.
CSS, yeah.
CSS.
Very good. It absolutely is CSS. And this particular one with the hashtag #myStyle here, what kind of styling is it?
ID.
Right?
Very much is a CSS ID styling. Very good. How about this one?
Class.
Very good. It's a class. Awesome. Awesome. All right. Keep on going here. How about this one?
Tag.
It's a tag styling.
What is it?
Absolutely
Oh,
right.
tag. Okay.
It's a tag styling because we don't see any like dot or hashtag before that thing. So awesome, awesome job there. One last one here. What is this one?
Tag and class.
Tag.
Space.
Kyle, why did you do this to me?
Class.
It's
It
styling.
is
Class.
technically a class styling specifically for div tags. specifically for div tags. So this class styling can only be used on div tags. It technically is still class styling, but can only be used in a certain type of tag, which again is the div. I know, I'm just starting out this class. Oh, Kyle, was a trick question. I was like, kinda. But isn't that fun to know? All right, I have angered enough people. Let's keep going. It's all in our head. Let's bring in some HTML to work here. Help me out. How would I add a title of the weather station to this page?
You would go into
Title tag.
I heard it, title tag, and then we're going to place the weather station right in there. Fantastic. Keep on going here. How would I add the JS file, my code, to this web page?
Style.
Body.
Script.
Link.
script.
I like it. Script.
SRC is equal to
I think I heard it. SRC or source equals to mycode.js.
Oh, I thought SRC was only when you got images. So SRC is when you're just grabbing something from somewhere else.
Depends. It depends on what tag you're using, because each tag has their own attributes to it. For the script tag, you use SRC. For the image tag, you'll also use SRC. But for locations of stuff, remember href is also a common attribute that you'd use with locations. So it all depends on the tag you're using. Now, there's a lot of tags out there, so should you know all these attributes by heart? No, you definitely don't have to. And if you work with Studio with me, you know that I don't even know them all by heart. So it is a-okay. Take note of it, though, because you are working in HTML right now, so you will want to remember it as much as possible to keep you from having to go back and looking up things. So yeah, SRC is what we're going to use for script. All right, let's keep going here. How about if I wanted to add styles.css to this page?
Link.
I heard it. Link.
Plus
Very
XML.
good.
Yeah.
Excuse me, what was that?
Href. Type.
We're going to do one. What was the first attribute before that?
Okay, then
The source.
source.
Not source. We're looking for one that starts with an R.
It's
REF.
It's REF.
Rel, R-E-L.
Yeah.
And style sheet. This one is telling us what, or telling our page what our link actually is. It's a style sheet.
Style.
The style sheet. And then what comes next? I already heard it. Then comes that href. So Beasia, to your point there, this is where that confusion comes in. It can use two different attributes technically to pull things in. That source and href.
What about type? Would you be able to explain that for just a sec?
Yeah, type is just basically denoting what is in the file itself. So you'll see a lot of text/CSS. That's telling our HTML that, okay, in this file, when you get in there, expect CSS to be inside of there. You can also use another type of a very common one is type could be JavaScript itself. It's really just the type attribute is just to give a heads up to the website, telling it what it's going to see whenever it opens that file.
Is it required or no?
Sometimes. It depends.
Okay. Gotcha.
Which I hate the most saying. I really do not like saying it, but it does depend. I don't exactly remember the specific circumstances in which you'll really want to use type, so I can't give you an exact example. But if it is in there, yeah, if it's in there, I would definitely recommend including it, especially if you already know the type.
Yeah, I was only asking because it made me get really hung up on the assignment, and then I found out that that was the only reason why I couldn't link it.
Yeah, absolutely. So include that type. And honestly, I apologize. I should put a type in here for link saying text/CSS. So great call out there. Awesome. Any other questions on what we just saw here? All right, let's keep on going then. You guys have learned a lot. Just think about that. We just did HTML, JavaScript, and you also know everything about the World Wide Web. So let's go ahead and talk about that. The World Wide Web revolves around your computer. We all know that. But we also have things on the other end helping us out with all that information because our computers just aren't big enough to store everything. What is on the other end that helps us when we want something from the World Wide Web? What is it called?
Server.
It's our
Server. It's absolutely right. Server. So a server's out there somewhere with all the information that we might want. Some of it we don't. So that's when we start asking for it. We're going to start asking for it by typing in just a simple address here, website.com. When we type it in there, press enter, it sends over information. But what is this called when we send it over?
Request.
Request.
A get
A request, very good. And this request was a website. But when we send over a website, what kind of request in particular are we sending over?
Get.
A
Get.
get request.
Very good, a get. When we want to view information, we send over a get. What's the other one that we talked about for bonus points?
Post.
Post. And when do we use a post?
Yes,
When I
most.
send info.
When we're sending over information. I think I heard it out there, but when we send over information. So on an event, when you click a button, and you click submit, we're
Form.
posting information to that server. Awesome, awesome. All right. Now remember, the server side is on the right-hand side, while the left-hand side, and I guess I didn't really put that there, but we have our server side. Remember, server side and client side. When the server gets your request, it's going to send back information. But what is this called?
Response.
Response.
The response. We're going to get a response back. Very good. And when we get back a response, we typically get in the form of some kind of information. In this case, we ask for a website, we get back a website. When that website is retrieved, our browser then compiles it and puts it onto our screen right then and there. That is how the World Wide Web works. That's how we get back our websites. Awesome. So that is what we have with websites. We're going to dig a little bit deeper here today. And I saw, Jody, I saw that you raised your hand. Did you have a question? Okay. Just want to make sure. Yeah, if you have any questions, usually when I mute, remember, throw them in the lecture questions channel. It might have just been misclicked, so no worries. Oh, because I usually don't check that. But, all right. So this is how we get back information about websites to actually view them. Let's go ahead and talk about what if our website has information on it that we need to retrieve. Now, what am I talking about here? When we ask for our bank account information, or excuse me, our banking website, it shows us whatever bank we work with. But when we log in, we're getting back information, in particular about our accounts, etc. We're getting back information from that server that's not the website, but instead data, information about us or our finances. So in this case, what if we on our site wanted to have maybe, I don't even know, sports scores or weather or just pictures of pets? Anything you want, information lives outside of there. So hypothetically, on our website on the left-hand side here, what if we wanted to add the weather to our site? Well, this is possible because in the internet or out in the internet, this information exists. Information is lying out there ready for you to use it. That's the beauty about the whole interweb and just being connected. That information is readily available. But where do we get this information from? How do these websites actually get it? That's where a certain tool out there in the web is utilized by developers. That particular tool is called an API. An API is where information can be stored. So let's go ahead and talk about that real quick. Again, I'm on my website. I'm on my website, and what I want to do is send over a request. And in this particular one, I already have my website, but in this case, I actually want to get the weather in order to put it on there. Now, this is a little different. What we just sent to was not technically a website. We're not looking to see anything. We're looking to get back information, get back data. When this happens, this kind of URL or link is more referred to as an endpoint. So if you hear me say endpoint, it typically means the URL that I'm using to request information or data. So that is what an endpoint is. So when we do that, when we come back here, we send over our request to the API using that endpoint. That server's like, oh, awesome, weather, I can definitely do that for you. It sends back a response. But unlike the responses we talked about previously, where it sends us back a website, in this case, it will respond back with data, the actual information that you requested, the weather information. From there, we're actually able to put it onto our monitors, put it onto our websites. And that right there is how the request for information will work. So I'm going to pause here just for a moment. So I got a question, Jody. My question is, how are other classmates unmuted? But when I try to mute, it says that it's not allowing me folks to mute. I don't know because everyone's able to unmute. Right now, you're not because I have everyone muted. I apologize. If you have a question, let me know. But it might be, I don't know how it's working over there, but everyone is allowed to unmute. I can't keep individual students, I promise, from unmuting. You're not being singled out, so I apologize. Yeah, Jody, I get what you're saying there. I do apologize. I don't know what's going on with your thing. If it continues to act up, I'd say try to log out and hop back in with Zoom. But if you hear other people talking, you're not on mute, continue to let us know. Hopefully we can maybe work on something. I really don't know. So I apologize. We can take a look at it later after class to see if there's any stuff wrong with Zoom or whatnot. All right. So any other questions about what we just saw here with the API? All right, then let's go ahead. What I want to do is that we said we're not getting back a website anymore. We're not seeing anything fancy. We're getting back data. We're getting back data here. So let's go ahead and actually see this in action. So what I'm going to do here is that we're going to go ahead and do a GET request from our browser. And we're actually going to be able to hopefully see this information. So you might have already seen this in your examples. I'm using the exact same one, the handlers.education.launchcode.org/static/weather.json. So what I'm going to do is go to this link. I just pressed enter in the URL and look at what I got to see here. Remember, when you send something in the URL, it's automatically a GET request. So I just sent over a GET request to this launch code handler that politely gave me back information. In this case, weather information. We want to even look a little bit further. We can go to our inspect, go over to our network tab. Got to press enter one more time here. We can even see weather.json comes back. Awesome. So we're able to actually see all this information come back. That's really awesome. So right now, we are able to process that. When we send out our request, we can actually get back some kind of textual information to possibly work with in the future. Now, the one thing I want to call out is that this is formatted in a very particular way, a very structured way, which is what you have to do on the web. Everything has to stay very, very structured, so we know how to work with it. But it's all about knowing what structure it exactly is built in. So we've seen those curly brackets before. We've seen a couple other things there before. So let's go ahead and talk about what this data actually is. So what we just saw is that our API that's sitting on the launch code side somewhere out there in the world just sent us a response to our computer. So let's go ahead and actually break down what we just saw. Coming back over here to this format, with these curly brackets and all of this textual information with these colons in here, you've seen something a lot like this. But I want to introduce you to the actual name of the response type we just saw. That is called JSON. In other words, if we broke it down, it's a JavaScript object notation. But generally, I hear people shouting JSON, JSON, JSON back and forth. But this is a very, very, very popular format to send information back. If you're curious about other formats out there, back in my day, because I'm an old guy, XML was a very fun one. You can also send back in text. You can also send back, of course, in HTML, things like that. But the one we're going to be really focused on today is this popular format called JSON. So bringing in that format that we just saw out there, what does it look very much alike? Looking at the curly brackets, looking at those colons, how things are on left side and the right side of the colons, what exactly does this look like? If you're shouting object at your screen, you're absolutely right. It looks a lot like an object. That's because in most sense, excuse me, it is an object. We're returning a response in object form. I'm gonna go ahead and put that out there. Give me 1 second.
Can't hear me anymore? Wait, how about now? All right, cool.
All right, there goes the headphones. I only got 10%. So I was jamming to tunes all day. All right, so why does it look like an object? Well, take a look at this. It looks like we have a key and a value pair. That's the thing that really denotes an object in general. But one small call out I want to show you here is that on our response, we have quotes on the left-hand and right-hand side of temp, status, zip code. Our keys have quotes around them. This is very common for a JSON object to have. And you'll typically have to include these quotes if you're creating a JSON object yourself, if you're not going through code. So that is just one minor difference I really wanted to call out there. Will it really impact you too much? No, not at all. But it is one thing to, if you really want to choose, if you want to know if it's an object or a JSON object, those quotes around those keys will sometimes really specify that right then and there. So awesome. That is our JSON object. So I'm going to go ahead and pause it right here. Go ahead and yell out any questions anyone has. That was JSON and our response object. Everyone's doing good? Everyone's like, God, this is so easy. Like, stop. Like, I'm just asking. Just want to make sure. All right, fine. Let's get stuff harder then. I'm just gonna be like, all right, time to turn it up to 10. I don't really have a 10 knob right now, but I will find one. Okay, so we're gonna bring it back over here to our response. And I do want to like just quickly show you right here. It is a very, very nice way. Objects are, it's called beautified in this browser, basically made into a pretty format that we can really go through because these objects do get more and more complex. So coming over here, we sent over this GET request using this URL. We just used it in the browser just to help us see this. But when our response came back, these are our headers, but our preview is what comes back. It's very much well formatted over here. So in the future, I highly recommend if you have things being sent back and forth between websites, go into your network tab, go under preview and see what's exactly going on. We'll see more of that becoming more apparent here soon. You'll also like that in assignment 5, I believe, and a little bit of assignment 6. It's just a small tool to make your life easier. All right. Let's go ahead and hop back here. So we know how our systems are talking, our browser to our server side and coming back and giving us that information. We just saw this though in the browser. Now ask yourself, do most websites talk in the browser right on that URL bar? No. They're talking behind the scenes, utilizing JavaScript and code to do that. They're not going into a new browser, typing things in and getting things back. They're using a very specific tool in order to do this communication. That tool we're going to talk about today is called fetch, or fetching your information using JavaScript. Now this is, I love this portion because this is one of the most powerful tools I get to teach you about in JavaScript itself, because now you have just exposed yourself or are about to the World Wide Web full of information. If you are a data nerd like me, I love spreadsheets. You get access to everything, the exabytes upon exabytes of information using just one simple tool out there that's already baked into JavaScript, the fetch command. This is a keyword here called fetch, where what it does is it takes in a parameter. The main parameter that we're going to be talking about today is the URL, the place where that information is living that you want for your website. And then comes something new that we've never seen before. We have our fetch URL, and then we do a dot then. A dot then. And then in this dot then parentheses, we include a function that says response in it. Now this is very weird, we'll talk about it, but just take close note to this. It says fetch URL dot then function response, and then just for fun, we're going to console log our response. So this right here is fetch in a nutshell. But things look better if they're not just there on a PowerPoint. So let's go ahead and get our hands dirty. What I'm gonna be doing today is working again with the Lecture 15 pet store. If you want, feel free to pull down any updates. I did include a new page. That one is mycode.js. If you wanna see everything that's changed in index.html up here, I included the mycode.js up there on index. So today we're going to be in my code in order to work with this fetch thing that we just learned. So all up to you if you want to include that. And that was what I wanted to mention in announcements, was that pull all the updates. Oh, Kyle, you should have wrote a note. I should have. All right, let's go ahead now and see fetch in action. What I'm going to do is maximize this a little bit just for everybody. I'm going to go ahead real quick. Go ahead and take that drink of water. I forgot to increase the font size here, so I'm going to go and do that. There we go. Go back over to my code. Did I not save that? Try one more time. Preferences, settings, font size. Oh, because I did not do that right here yet. There we go. That would be nicer. All right, that's a little bit bigger there. Awesome, awesome, awesome. All right, let's go ahead and do this. Now, again, we want to learn fetch, but before we even do this, I'm sorry, we can't just hop into fetch. We need to first understand or remember when we are trying to do something on a website, we need to wait. We need to be patient before we start doing a bunch of stuff on there. What does everyone remember? And I believe you all can unmute. Yes. What is the one thing we need to wait for before we do all the fun, heavy lifting of working with our white websites? What's the event?
Load.
Very good. When in doubt, wait for the page to load. So that's what I'm going to do right now. I'm going to create an event listener for our load event. So window, I just searched participants for window dot add event listener, and I'm going to wait for load. And then I'm going to write my function, of course, what I do after my page is loaded. So there we go. All right. So now I'm waiting for my page to load. Now I can go ahead, after my page is loaded, write some code to execute. Let's go ahead and work with that fetch and see what happens. What I'm going to do is type in that keyword, which was fetch. I'm not going to do that. Fetch, and then I need to include my endpoint. Remember, endpoint is the thing that touches the server. I just left it up here so I don't have to go looking for it. That URL is a string, so I type in that string. And then who remembers after fetch, after it executes, what's the next thing I need to type?
Dot
Then.
Dot then, yes, the thing that comes right after. Dot then, and then I write another function, close parentheses, like that. What I'm going to do is I'm going to put this dot then right below here just so it can format. This is absolutely okay. JavaScript knows that you just want to put it down one line, but this is also going to help us so we don't have to keep scrolling back and forth. And I heard it out there, very good. We need to get back the response. All right. And now what I want to do is console.log here and then type in that response. All right. Let's go see if this works. Like 50-50. Of course, that's what you guys want to hear. It's my website. We'll go all through it again. I'm gonna go up to 15 here, double click on my index.html, wait for Safari to open. There we go. Copy this because I do not want to work with you, Safari. I'm so sorry. Come on over to our browser and paste that in there. There we go. All right, it's in here. I'm going to right click, press inspect. So our panel opens on the right hand side here. Come over to our console, and I got to see a response. Neat. So let's go and see what this response object looks like. So in our response, we have a bunch of stuff in here. The things that you're going to care about most is the body, the things that we get to see or work with. So it's a readable stream. What the heck does this mean? It means that it's all packed in tight in bytes, in bits, ones and zeros, to make everything much more lightweight as it's sending over the internet. You wonder how your sites get to your page so fast? It's because everything has been learned to get crunched down as much as possible in these readable streams. So in order to read readable streams, we need to do something more to the response. What we need to do is tell our JSON, or excuse me, tell our browser to read it as if it was looking for JSON. So what we do there is that we need to parse out the JSON. So we say, let my response JSON equal response.json. I think this is it. Otherwise, if I'm might be misinterpolating. Well, let's take a quick look here and see what we get. Not that what I needed. I'll go back to here in a second. I just want to make sure I'm not going the wrong way here. It is a promise. That's what I thought. So we are going to not do that and instead return our response.json. And we'll talk about what exactly these dot thens are, I promise. Yeah. And then we're going to say is function response. So put my, there we go. Console log response. Now, let's go ahead and see what happens here. 1, 2, 3, 4 function. What are you doing to me?
Function
You
spell on
misspelled function.
I really? Oh, of course. Someone told me that today in like a coding like review that we did in works. Like, you spelled, is the name of a service. So you spelled this wrong. I was like, well, I can't spell. That's why I work with an IDE with the spell checker. And why, yeah, okay. What are you doing to me? And, oh, I didn't save it. It was like, it should not be a promise. There we go. Perfect. All right. And now what we just did is fetch that information and we're able to view it. Exactly what we just saw on our screen when we typed in the URL, but now we're actually seeing it as a console log. So actually in our browser, all this information is coming in. Now this is awesome, but you're probably like, Kyle, I have no idea what you just wrote. Like, what the heck was all that stuff? That is a great point, and you should yell that a little bit louder at me next time, because let's go through exactly what this stuff was. You already know fetch. I professed my love for it. You know this thing will help us get information from the web and back. Awesome. But I typed out this next thing here, this dot then. What this is, if you wanted to break it down just into just some plain old English, it means that after that fetch is done, then do this. That's it. After this fetch, after I'm done getting that information, do this. Now remember, to prove my point that I'm not lying to you, remember when we send out that request and we get back a response, we just did a fetch. So coming back is the response, and then the fetch is done. Hence why we have the parameter in here called response. So it did the fetch, it got its response, and passed it down next to this dot then. So think of it, it passed information to this then. It's like, hey, I got this response back. Do whatever you want now. And this section of the code is like, okay, cool, let me do my thing. That's what dot then does. So let's talk about what this highlighted section's thing is. What it's doing, again, remember that readable stream I told you about? Things are coming back in ones and zeros. Really hard to read from us. We do not want to see that, especially on a Monday morning. So what we do is we use a response.json. What this does is it translates that stream into the JSON object and then returns it. But remember, this takes a little bit of time. So we wrap it in a then to say, okay, take your time. And then when you're done with that, come down to this portion of code. And it passes that response down once again, whatever's returned from this .json. And so that's that parse stuff. And then we console log it. So in the end, this is what we end up with. The parse JSON from that response body, or from that response. Rena, to your question, is a response a class instance or what is it? A response in the consideration of a fetch is an object. You can also refer to it as the response object. As we saw in that response object, it contains a body. That body is what's important. That's what contains the readable stream that we convert into JSON.
Thank you.
You're welcome. Absolutely. And great question. I'm happy to break that down. And then finally, we have our response that's all translated and we're able to console log that now. So I'm going to pause here. This is fetch in a nutshell, a very big nutshell. But what questions, I'm happy to answer any other questions that we might have about this.
Can I ask you a question, Kyle?
Yes, so. What's up, John?
Yeah. So is there, I guess, like any response that we get, I guess for now that we do convert it into JSON, but is there could we not work with could you not work with just like the response object itself not turning into JSON?
So you're asking, can the response object come back with something other than JSON inside of it?
Well, I guess that's another good point. I guess, yeah, that too. I guess my main question was: is there a need for us to? I guess like is it just like a procedure like that that it follows that is there a need to convert like a response object into like a JSON format?
Is there a need to convert into the JSON object?
Oh, I guess I guess I should word it differently. Like, could we still work with an object, like response object, without turning it into JSON?
Technically, depending on the response object that you're working with, but most likely you'll be converting it over to JSON and then working with it. You need to transform it into something workable. Something usable.
Go ahead. I'm sorry.
Oh, no, that's about it. Go ahead.
So it is response object not like by itself not workable then?
In some sense it is. So it depends on your response object coming back and what you're utilizing, but in most regards with fetch, I'll say that more, that with fetch, you're going to have to transform it into JSON. So when you're working with fetch, there's multiple ways to talk to the internet. Fetch is just a very, very, very much used one, and it's also baked into JavaScript. So when we're using fetch, we need to use this response.json in order to utilize what comes back from the response. So to answer your question, unfortunately, yes, most cases you're going to have to use the .json in order to work with this.
Got it. Thank you.
Yeah, absolutely. And to further on that too, if there are use cases where you don't have to use it, yes, but we won't be really getting into those. So do use your response.json. All right.
To piggyback off of what he was asking you, is it because of the information that we're fetching is already in a JSON format?
Absolutely, yeah. If you're trying to do that JSON convert on something textual or even HTML, you'll get an error here. So you must trust that your endpoint is actually returning JSON.
Okay.
Very good question.
I have sort of a random question. I'm just wondering if do you find in your job or in most coding jobs that you need to log things to like the console, like you showed us on an inspect element? Like, is there like a debugging reason for that? Or do we just get to learn it because it's good to know sort of thing?
I personally use console logs for my responses all the time. I'm a console log debugger, though there are other ways. I know developers out there are probably just like throwing things at me right now hearing that, but I love using console logs in order to debug. But showing it also too is a good way to just know what's coming back from an API. The first time you connect, you kind of know what you're supposed to be getting back, but you don't actually know the true structure. So a console log is a great, quick, dirty way to just see what exactly is coming back. So that's why I like to use this console log. So to answer your question, yeah, all the time. And console log is a great way, I feel, to actually see what's going on at that moment. All right.
So quick one, Kyle, if you have a second.
Oh, yeah, Ben, go ahead. And then Hannah, I heard you next.
So the URL that we're using in the fetch part, like this kind of one, we got the example for like the weather stuff. Mm-hmm. So we got that one because like it's ours, I guess. But what's kind of what's the limit of what I can go get as far as information on the internet? Or is it, packaged in a certain way? Or is there some database I can look at? Or like, how do we like decide what to get and how to get it?
It depends on what your application needs. If you're creating a financial application, you need to go attach to stock market information, which is readily available on Yahoo APIs. If you need to create a weather station or you're just creating a website to show weather information, you want to connect to the weather API. Or you can connect to Open Weather API. If you're trying to do sports code, you can connect to, I don't actually know any sports codes, never had to do it, but I'm sure DraftKings out there has an API also for you.
But most of that's already out there, you mean, and we just have to look up how to get to it.
Absolutely right. There are thousands upon maybe millions of APIs, people out there just putting data out there for you to take control of and do something with.
Okay, got it.
Yeah, absolutely. Absolutely. Awesome question. Yeah, the data for anything, literally anything. Just like there's an app for everything out there, there is data for something that you need to do. And if there's not, make the database yourself. We'll learn that. We'll learn that eventually. But there most likely is an API for whatever you're looking for.
Cool.
Yeah, great question. Hannah, did you have a question there?
Yes, Kyle. Like the response.json, is it like a static file of an array of objects? Because, you know, the URL we gave as a parameter to fetch in line 6.
So
that showed up in my browser as a just like a static file with an array with like 6 objects inside.
So what JSON.json does here is it's called a parser. So it will take what's sent over from the fetch and transform it into JSON, or workable object, or usable object, something tangible. So think of it more as something that transforms unusable stuff into an object that we can actually take advantage of. So it's more of a parser, if you will.
Oh.
So it depends, and to answer your question about the arrays or objects, it all depends on what's the other side of that API. What we're going to be getting back is exactly what they have here on the API. I can't get anything different because this is what this static page gives back to me. But that .json doesn't care where the information comes from. It just cares if it's JSON, parses it, and gives us back an object to work with.
Oh, and we can only access it through JSON. Like give it an index, like JSON of, like we did that in the exercises. Like JSON of 0 will give .name, gave us the name of a planet. So is that what you're saying?
So this portion that's highlighted on the screen will get you that JSON object back to do what you're talking about.
Okay.
It'll hand you back an object so you can call to the name. It can call to that planet information.
Okay.
As long as you're providing that planet URL up there. But this portion right here, what it wants to do is just go out, get JSON, come back, turn it into an object and give it to you. Doesn't care what it actually is.
Thank you, Kyle.
Yeah, absolutely.
But finally figured out the unmute thing. The Zoom pops up a window when a thing is being recorded, and if I don't dismiss that window, I can't then unmute for some weird reason.
Good. You got it all figured
One
out.
shouldn't have to do with the other. But so hold on. When you go out and fetch, though, there's no guarantee that what you are fetching is in JSON format. So how do you? I mean, there's no guarantee that you might get back XML, you might get back XHTML, you might get back HTML. How do you?
Yeah, and the answer to that is don't talk to strangers. So what I mean by that is that you need to know what API you're talking to before you go request information from it. So you need to be at least reading its documentation before you actually connect to it and know what to expect back. So whatever URL you place in your fetch, you should know what to expect back, at least in the most limited sense. Know it at least in JSON if you're working with JSON. But in the end, don't be plugging in random URLs and hoping that you get something back. That is how things break. So yeah, you definitely want to know what you're actually connecting to beforehand.
So basically, you want a guarantee.
You want to know who you're connecting to. So yeah, you want to be guaranteeing knowing who you're talking to is who you're trying to actually talk to, so you can actually work with what information is coming back. Great question there. All right, I'm seeing a few other here. Okay, from Veneer, would fetch still work with local at-home servers versus cloud-based or normal server setups? Like if I have a mini server set up for storage, we're able to fetch computers. So technically, yeah, as we talked about with IP addresses, everything is connected. So you can technically fetch information from anywhere in the web, in the world, including your local devices. Now, that being said, you on your local network can only connect to your local devices. So yes, you can share information, you can fetch back and forth, but it is not as easy as I'm explaining it. There are extra steps in there, and you need to allow access to that stuff, make sure the data is there, etc. But it technically is possible.
Well, couldn't you just substitute a direct IP address instead of a URL, like a actually name URL? Couldn't you just say fetch, I don't know, 192.168.1.6? Let's say that's a computer connected to your router. Can't you just?
You're doing the work of the DNS. You pay for that DNS. I would recommend using the DNS. But if you want to plug in the direct IP address, your ISP or your internet service provider can still get you to that URL.
Well, 192.168 would be on your local network anyway. It'd be one of your devices.
Yeah, absolutely. If you type in 192.168, etc., you're going to be trying to connect on your local machine to another device. If that device has no ports open for communication, you're going to get back basically a 404 at that point.
Correct. Yeah, you're gonna. Yeah.
All right. So I got that one. Hopefully, even here that helps. Console log is only for JavaScript, not for Java. Java has its own printing method. Rena, yes, you are correct. We're not in Java right now, but you are correct. Those coding structures are going to be a little bit different. Jacob, is the response passed in the parameter the information you are referring? Is the response passed in as a parameter the information you are referring being fetched, just given a name to reference on line 7? I think I followed that. I think I just had like a huge mind blank right there. And I apologize. It's not your writing. It's just me with caffeine going down. Jacob, can you explain that to me by any chance?
Yeah, I'm just curious. On line 7, the function response, is that response referring to what we're fetching?
Yes, that response on line 7 is what's coming back from the fetch itself. So that response object that has that untangible or intangible body. We can't read from it. So that's what this response has. And then we transform it into something readable using this line. Once that's done, it's passed down here as something we can actually use, a JSON object.
That makes
Kyle,
sense. Thanks.
Last question, Kyle.
Yeah, what's up?
So I guess picking back of my first questions from earlier. So I'm seeing actually at the URL that it ends in weather.json. So is this kind of like, so I'm kind of confused as to like, okay, so you're fetching a JSON object, but you're receiving it as like a response object, but you're parsing it back to JSON?
Yep.
So I guess it could.
Again, it's sent to you in a very crushed way. It's sent to you in a way where it's the fastest possible to send it over to you in a very condensed means. So you need to make sure that you basically take it out of the package and blow it back up into JSON. And that's what this line does.
That answers my questions. Thank you.
No, awesome. All right, got one more question here. We got to move on here. So I got it. Henry, does the URL that we use, Jason, Henry, does the URL we use for the fetch function always end with the .json if it is in JSON format? No, it does not. It does not. Sometimes the endpoints do not have an extension on them at all. If we have time at the very end, I'll show you another one that will basically not have that extension. But just for this example, it has .json. But no, great question. Not all of them will. Awesome, everyone. Great questions. I love this thing. Oh, all right. Let's keep on going here. I hope everyone loves fetch. Like I said, it really does open ourselves up to the entire web full of information. Data is out there and accessible, and we can now work with it. So one thing I want to show you here is that, so let's go ahead and run this fetch. And what I want to say is that down here, I'm going to say, look what I'm doing here for the console log. This response has returned. And I spelled return wrong, of course. R-E-T-U-R-N-D. Okay. We're going to do a little bit of magic tricks here. And you guys are probably going to get really mad at me. And down here, I placed a console log with I'm here. Now, take a deep breath. I'm going to save this. We're going to come back over here. We're going to go to our console. Oops, excuse me, I'm going to go over to the pet store. I'm going to go to our console, and I'm going to refresh. Now take a look at this. The first console log says, I'm here, and the second one says, this response has returned. Let's go back over to our code. If we look at this fetch, this response has returned is before, and I'm here is after. I have been telling you since the day one with our cake recipe that everything goes sequentially. Everything goes sequentially, and I have not lied to you. We are now just getting into a very different topic about how things moving sequentially truly kind of work when we're trying to talk to things that might take a while. So this is what I want to talk about next. Let's go ahead and do that. We're going to talk about what we just saw, but in a different sense. Let's talk about what everyone loves to do on their Tuesdays or on their Sundays. We're going to talk about laundry. Now, picture you with 3 buckets of laundry to do, like I kind of do right now. Thank God my camera is pointing this way, so you can't see it, but say we have a lot of laundry to do. If you're like me, I only have 1 washer. So as we're doing this, I have to wait for each load to finish. And I'm just waiting there. When everything gets done, I can move on and do my next load of laundry. This takes forever, one after the other, each bag of laundry. How I just did this. No, oh my gosh, I cannot answer it today. Can you guys hear me all right? No, I don't let you unmute. Sorry, I'm having technical difficulties today. Can anybody unmute real quick and say hello?
Hello.
Awesome, I can hear you through my headphones again. Cool.
You're right.
I can hear you, but it's kind of garbled.
Is it really? Do I sound like a robot?
It's just barely.
Ooh, maybe I should switch off my headphones. So I'm just wasting time. Is it still gargly?
Worse now.
There we go. Exactly. Just a microphone, please. Thank you. And same system. All right, trying again. Can you guys hear me? Is it less gargly this time?
Yes, it's good.
Yeah.
Okay. We're going to stay like this then. All right. Anywho, let's get back to laundry. All right. Synchronously. Thank you. There we go, Kyle. Now you have a brain cell back. We're doing this synchronously. So we're doing it one after the other. So one thing at a time. This takes forever. So talking about these 3 loads of laundry again, wouldn't it be beautiful if we had 3 different washing machines to do all of this at one time? When we have 3 washing machines, we're able to do those 3 loads right then and there, because each of our washing machines are running right then and there. This is called asynchronously or asynchronous. We are able to do all of these tasks at once. All these tasks at once. We're able to split up and divide our tasks and let each of these machines do it. So this is asynchronous. Now, why am I telling you about laundry and asynchronous? Because what we just saw explains the phenomenon that we just saw in our browser. So let's bring back that code that we saw. Now, take a look at this. Fetch is a very specific type of function, in which it's called an asynchronous function. So what this means when it's an asynchronous function is that it's saying that this fetch is saying, keep going. I'm going to do my own thing. I don't care, split off. What just happened is an asynchronous task just happened. So what happens is that your compiler is like, okay, I'll wait for this fetch to finish up. You keep going and doing your thing. It's like, okay, I'm gonna come down to this console log and says, I'm here. It's like, neat. These things that just happened again is called being asynchronous. 2 tasks were just created, 2 separate tasks in one application. So basically, JavaScript said, I'm going to wait for this thing to happen, but keep on going. We don't want them to wait. Hence, 2 tasks are there. Now, the question is, why was I'm here beforehand and not the other? So let's go ahead and see what happens. Task 1 is going to go down after it's done fetching and do the console log of the response. So what this does is that it is waiting for it to actually come back. So I'm gonna go back there. So let me actually go back for a moment. So to answer the question real quick about why was I'm here above our response coming back is because the fetch takes a while to go all the way out on the internet, find what you're talking about, and come back, while the second task just completes right then and there
because it's just a simple console log. So it's all about timing. Things are on a timeline in JavaScript. So one thing about why it's waiting, or these asynchronous things and how things wait, again, if we move down here, is called giving it back a promise. Asynchronous methods have to give back a promise, like a pinky promise. And that pinky promise is that I will return eventually. I will return eventually. That is the promise that our asynchronous methods give it. And JavaScript's like, okay, I trust you. I'm going to keep moving on. Please don't hold up everything and do your own thing, get your task done. So again, our promise is I will finish eventually, but please wait until I do. Now, that right there is asynchronous methods. Again, it's splitting off the previous path and doing its own thing. Everything still goes sequentially. It's now just two different things going at a different timeline. Now, if your head is starting to hurt, it's okay. This takes a moment to just process exactly what's going on. But just know when you're looking at this line of code and you see asynchronous method, particularly fetch, just know that it's going to do its thing while your code continues to run. And that's what we're seeing over there in our code. Now, one last thing I want to show you and talk about is that what if you don't like this? What if you don't want your asynchronous method just to run? Then we use another kind of keyword to tell it to wait. I don't care if you're asynchronous. You're going to wait until everything is done and then we will move on together. Because maybe, I don't know, they have like separation anxiety or something like that. They don't want to move on. So we need to wait for our fetch to finish. We need to wait, AKA await. The keyword we'll be utilizing to wait for an asynchronous function to finish is called await. What this means is that at this line, at line 6, my code will stop here. It won't split off into another task and wait for our fetch to come back with everything finished until it comes down to line 13. Now, one last thing also I want to put in here. I'm going to put async up here for function because awaits can only be in fellow async functions. This is how you make a function asynchronous, is async here. So let's go ahead and see what happens now. I'll come back here, refresh, and take a look at our response now. The response returns first, and then I'm here, comes back. Going back one more time, I'll take out await, save that, refresh, and I'm here is now the first method. What you're seeing here is JavaScript itself splitting the two tasks when we don't await for it, and then keeping it as one when we do have the keyword await. All right. There we go. I'm gonna unmute. Please don't yell at me too much. How does everyone feel about that? Any questions?
Kyle, can you please show the code one more time with the wait statement, please?
Absolutely. So Kyle, quick questions. So if I were to put this like in an analogy, I guess, from client to server, or I guess any sort of communications, I guess synchronous would be like, I guess if you were to like, let's say program like a chess game, then I guess you would have to wait for another player to make to finish the turn. So that would be more of a synchronous, right? And I guess, is that a good analogy to put it?
If you want to, yeah, absolutely. Asynchronous would be you have to wait for the other player to move before you do.
Right. So an asynchronous would be, let's say, like, I guess, like, let's say if I were to put this in an analogy, it's like a game. Like, if there's a bunch of things going on, that would be more of like asynchronous, right?
Asynchronous as a game would be more like a multiplayer, like
right.
Warcraft. Every character is doing their own thing whenever they want.
Gotcha. All right, cool.
Awesome. Any other questions out there?
I just think it's kind of interesting. So maybe I want to make sure I have it right. So it's an asynchronous function, which means asynchronous means you can go whenever you want. but then we're creating an await that makes it not go whenever it wants.
Mhm.
And I'm trying to figure out why the function is still asynchronous, but maybe that's just like a weird thing, right? Is it because of the await you said?
So we have to make it asynchronous up here because we're utilizing the keyword await.
Okay.
Isn't it? Let me see if I understand it. So if you and I were taking off on a run and we both decided we wanted to take a different path,
Mhm.
but we want to meet up to cross the finish line together is what the await is essentially doing. We're both going to go our own way, but we're going to come together and then cross the finish line together. So I'm waiting for you or you're waiting for me, whoever gets there, to do it together.
Think of it this way. We're off on a run together. I see a lemonade stand. I'm like, heck yeah, lemonade. That await right there means you have to be patient and wait for me until we move on.
Okay.
And then we continue. Now, the second I take this await off and I stop for lemonade, you just are like, heck no, get out of my way. I want to get to the finish line.
Okay.
And so also an asynchronous function can go asynchronously. That sounds dumb, but I'm just trying to make sense of the words.
Yeah, it's okay. Yeah, an asynchronous function, when we denote that it's an asynchronous function, means it just runs on its own time, splits into its own task, does its own thing.
So
But in the end, go ahead, Henry.
Did we add the async because we added the await, or is the async required?
It's not required if we don't have the await. So to answer your question, you are correct. We added the async because we added the await.
So I think what had confused me or initially was because like it being synchronous means that like it's just going, or the code is being read from top to bottom in order. But like, not to use another analogy, but like for the cake analogy, right? So like the first step is to preheat the oven, and then the second step is to add the cake in the oven, right? Now, being synchronous, it would preheat the oven and then just put the cake in there right after that's done. But we're doing what we're doing here with the async function, because although it was read in order and like it preheated the oven, we have to wait until the oven's done preheating before we go on to the next line.
Correct.
Is that what it's saying? Okay. All right. That makes sense.
Is the await line part of the fetch code, or is it a separate line of code?
It is a keyword for any asynchronous function. So you can await any asynchronous function. Fetch is just the first one we've learned about.
Well, no. What I mean is, did you stick the await word inside of the fetch code, or did you stick it somewhere? Like, I can't see your code.
I apologize. Yeah, await, it goes await and then space and then fetch and then the parameters for it.
Okay, so it is on the line with fetch.
It is. It is just before it with a space between them.
And where's the async? Where did you add that?
Async was on for the line 4 with the window.add event listener, parentheses, quote, load, end quote, comma, async, space, function, and then continuing to write.
Okay. On a side note, can I see you after class for a couple of minutes, please?
Yeah, absolutely.
I've got some questions related to another thing, so.
Okay. Yeah, absolutely. I'll stay on.
All right, cool.
All right. Any other questions here? Because I want to, if you guys are willing, I'll show you one cool thing at the very end.
Go for it.
Where I see one person typing, and then we'll go. How long is too long for to wait for fetch? Depends on your user, but I'll give you this. A user's attention span's less than 30 seconds. So less than 30 seconds. But it all depends on your application. It really does. So great question there. It all depends on what you're building. If you're getting back a lot of data, I mean, it can go up to a couple hours depending on what it is. Just because there's a lot of information out there, and if you need a lot of it, it's going to take a while to get back. But for stuff like this, just putting weather on the website, a few milliseconds. So all depends. All right, let's go ahead real quick. And what I want to do today is that all the stuff that we did with the fetch, what I want to do is that if we pull down this pet store, I want to make sure my users are informed with good information when they come to my pet store. So one thing I have right now is house cats can run up to 30 miles per hour, 48 kilometers per hour. But what if we wanted to get back a bunch of random cat facts all the time? Well, guess what? Like I said, every bit of data you've ever wanted is out there, and even cat facts are out there. So let's go ahead and update this section right here, which is something that, we all want to know. We want to know things about cats. So let's go ahead and do that. What we're going to be doing today is continuing to use this window event listener, but what I'm going to do is comment out this code, and we're going to write some new stuff. If anyone does pull down this at the end, I'm going to go ahead and put this just below here. But what we want to do is still get information back, wait for our page to load though before we do, we're going to be doing a fetch. Now with these fetches, and typically if we're ever writing in JavaScript, what we want to do is not just write it in our window add event listener, but sometimes you'll want to just put it into its own function. So what we're going to say is function get cat fact. Just like that. So this function right here is actually going to return, or we're going to use this to get back some cat facts. So that's what we're going to do real quick. So what I need to do to actually talk to it, we're going to start with fetch. And if anyone's wondering where the cat facts live, it's right here at cat fact. Did I just find this right before this class started? Absolutely, but I was like, why not just see cat facts? So after we write our fetch in here, we're going to do our what? What comes after our fetch?
Our dot then.
Very good, dot then. And what does this dot then have inside of it?
A response.
Get a response, but of course we need to write the function first, and then inside of there we put our response. Is this response readable?
Probably not.
Probably not. What do we need to do to make it probably readable?
JSON, yeah.
Spell return right first.
Touche. I'm watching you. Response.json. There we go. Awesome. And now we can actually work with our stuff. So we say dot then. Just like that. All right, let's go ahead and console log our response, and let's see what we actually get back. Now, first things first, we, of course, as always, we can take baby steps. What am I missing? That's good. That's good. Not good. All right. After the event listener on load is triggered, we can get our cat fact, just like that. Let's go and see what get cat fact actually brings back. So I come back over to my site over here. I'm going to go ahead and refresh this. And I see that things are returned 5 fun cat facts, but take a very close look at what this looks like. It's a lot more complex than what we saw before. Objects out there that we get back are going to look a lot more complex than what we just saw in our weather static JSON. So this is one thing. Created at has a timestamp, deleted is false, source user. Basically, what we care about right here is the actual cat fact cells, this text. That's awesome. That's what we actually care about. But this object will also give us a bunch of information also. Is it still valid? Blah, blah, blah. Whatever the object has in there, sometimes it is useful just to take a look at what we're actually using. But the biggest thing to note is that we are in an array. So if we're in an array, we need to work with it in a certain way before we actually get our object itself. So let's go ahead and do that. I know that my response is going to be an array of cat fact objects. So what I'm going to do just for this one is I'm going to return a response at index 0 is arbitrarily chosen. I just want to get back the first cat fact. And in there, now I have my object. I want to say I want back the text. Awesome. Then what I can do here is I can say, let my cat fact equal whatever's fetched. Now the thing about this is that if I fetch this and I just saved whatever this is back to my cat fact, we're not waiting for the response. We don't have a response ready to be given back. Again, it's giving back that promise. It's giving back that promise. So what I do is I need to make this first asynchronous, and then I put a wait. So we actually wait for everything to run and return us back that cat fact, and we put it into this variable here. And then we can return my cat fact. Just like that. Awesome. So we have our cat fact back, and it's being returned out of this function. Up here now, we can get back the cat fact. Just love how many times I get to say cat fact in this example. My cat fact. There we go. Now again, this get cat fact is asynchronous. It's going to split off and do its own thing. But I want to wait for my cat fact to come back. Please come back, cat fact. And so I need to wait for it to return. Just like that. And I can use a wait here because I have my asynchronous method. Awesome. Let's go ahead and console log this and see what we get back. Save that, come back over here, refresh, and look at what we get back in the console log. Cats make about 100 different sounds. Dogs only make 10. Well, you know what? Dogs don't have that much to talk about, maybe. All right? Jeez. All right, awesome. We got one cat fact back. Let's go and change this to 1 so we get a different one next time. Because remember, we have an array of 5. You can choose 0 to 4 then to get back whatever cat fact you want here. So anyway, I get my cat fact back, but now I want to actually set it in my website under this did you know. Now that I know that, I can go over to my index.html, find that did you know section. Where are you actually? There it is. I can see that the fact is right here inside of this span element. Span just means you want to place text in line with something. And I see that my ID here is animal fact. Now hang up. I know that if I have an ID, what can I do with that in JavaScript? If you're thinking to yourself, yeah, what was that?
Get element by ID.
Very good, absolutely. And then we can work with that. Awesome. So going back to my code here, what I can do is get that element using the document. Get element by ID and get rid of this thing. I don't like how it automatically does that. And my ID was animal fact. There we go. Our document comes back, or our element comes back. So we say let my did you know element. ELE. There we go. Awesome. So we get our element back, and now we can say my did you know element dot inner text equals my cat fact. Save that. Come back over to our screen, refresh. And did you know domestic cats spend about 70% of the day sleeping and 15% of the day grooming? Well, now your user does, because you're pulling that back in from an API. So somewhere on the other end, if they're consistently updating their cat facts, your users are also getting those updated cat facts, making your website one of the best on the web. And that right there is the best utilization for fetch that we can use with websites. So I'll just pause there for a moment. Any questions on what we just saw?
Oh, I have 2 questions. Well, now you went back. I needed to see this screen still, but also I was wondering, would you be able to use like a loop and then like the random number generator or the code that we use for that to like have it display a random one from that array every time?
Yeah, absolutely. You can use the random number generator down here and just choose something random here. Do I remember that off the top of my head? Let me actually see if I have that code for me.
Henry, I was thinking that question too. Like, how do you just like have it constantly change on its own?
Yeah,
right.
Rando int equal, what was it? Math dot floor math dot random. Oh gosh, and this is where it comes in. Anybody remember it off the top of their head?
What is it, divided by 10 times 10 or something like that? It's some weird.
That one is to make a decimal in the 2 fix.
Okay, yeah, that's
for the 5 elements.
This one. There you are. I'm going to just borrow you for a moment. Let's see where they're. Int. So our max is 4, or the length of our response. We can say actually response.length because it's an array. Our min will always be 0, so we can actually just take that out because anything minus 0 is same thing. Our min is also 0, so we can actually just take out that as well. So we can actually just save that. Let's go and see what happens now. Look at that. Oh no. Oh no, it is switching around. Cool. I love this one. It's just a random in there. I don't know anything about cats. I don't know who added this, but it's like, all right, it's a random cat pick, I guess. So yes, that was how you could actually add the random number generator. I love that. I was thinking about adding that in. It's like, oh, I didn't want to throw too many things, so I'm happy you called that out. Any other questions about the code we just saw here? Nothing? Oh my God.
I have one, Kyle. It's on the questions thing. Like, how do we know how many facts are generated? Like, I posted it on the lecture questions.
How many facts are generated? So I see this with the planets. With this one, again, we need to see what our object or our response is. So we know what our response is because we console logged it. So what you always want to do is make sure you take a look at what is being responded back. So I'm sure they know there was at least 2 in there, or whatever this example is trying to do, because they looked at the object. So we print out this object here, we see that there's 5 objects in the array.
Mm-hmm.
So how we know it's there is that we actually take a look at it. So you're going to want to console log your responses.
Okay. Thank you very much.
Yeah, absolutely.
Can you please keep the code just for a second? Just for
Absolutely. Stay over here. All right. Any other questions here before we are all done?
Thank you.
Absolutely. All right, everyone. Then that is officially it. Awesome. That is fetch. Pretty straightforward, right? Fantastic, everyone. All right.